Hello and welcome to this lesson on the limitations of metal extraction. In today's lesson, we will understand the limitations of the Earth's metal ore resources and explore the implication of these limitations for the mining industry, before discussing alternative methods to extracting metals, such as phytomining and bioleaching. So far, you are familiar with the methods of metal extraction, such as electrolysis and displacement reactions. This lesson will expand on your knowledge by highlighting limitations with these approaches and alternative methods to meet our demands for metals. Firstly, it's important to recognize that traditional mining methods, which typically involve extensive excavation and processing of ore, are facing significant challenges. These challenges are driven by three main issues. Firstly, Earth's metal ore resources, such as copper, are limited. As we extract more of these ores, the remaining ores are of lower quality, which makes extraction more difficult and less economically viable. Secondly, traditional mining can be highly destructive to the environment. It often results in habitat destruction, soil erosion, and contamination of air and water sources. Finally, the cost of mining increases as the quality and accessibility of ores decrease. This includes the cost of energy, labor, and machinery needed for extraction. To address the challenges we just outlined, scientists and engineers have developed alternative methods for extracting metals, particularly copper, from low-grade ores, which are less detrimental to the environment. Two such innovative methods are phytomining and bioleaching. Let's take a closer look at phytomining. Phytomining is a technique that uses plants to extract valuable metals from the soil. Here's a step-by-step breakdown of how it works. Phytomining begins with planting certain types of plants in soil that contains metal compounds. These plants are carefully selected because they have the ability to absorb specific metal ions through their roots. As these plants grow, their roots take up metal ions from the soil. The metal ions are then transported to and accumulated in the plant's tissues. Over time, these plants concentrate the metal to levels that are significantly higher than those found in the surrounding environment. Once the plants have grown and accumulated a sufficient amount of metal ions in their tissues, they are harvested. This usually involves cutting down the plants and collecting the biomass. Next, the harvested plants are then dried and burned to produce ash. This burning process helps to break down the plant material and concentrates the metal compounds in the ash. The ash, which contains metal compounds, is then collected and further processed. From this ash, the metal compounds can be extracted and purified to obtain the pure metal. Let's contrast this with traditional mining methods. Traditional mining involves digging and extracting metal ores from the earth, which is typically energy-intensive and leads to large-scale environmental disruption. In traditional mining, large quantities of rock and soil are excavated, creating significant land disturbances and potential habitat destruction. The process often requires the use of heavy machinery and significant amounts of energy, contributing to greenhouse gas emissions. Finally, toxic chemicals used in processing ores can lead to pollution of water sources and soil degradation. Phytomining, on the other hand, offers a more sustainable approach. It uses plants to extract metals, which means there is no need for large-scale excavation and land disruption. The process is generally less energy-intensive, as it relies on natural plant growth, and phytomining helps in bioremediation, improving soil quality and reducing pollution by extracting toxic metals. By leveraging the natural abilities of plants, phytomining provides a greener, more eco-friendly method of extracting valuable metals from the earth. Understanding this process highlights how innovative techniques can address environmental concerns associated with traditional mining methods, making phytomining a promising alternative for the future. In bioleaching, specific bacteria are used to break down the metal sulfides in ores. This process is a fascinating application of microbiology within the field of chemistry and provides a more sustainable approach to metal extraction compared to traditional methods. So, how does bioleaching actually work? Let's go through the basic principles step by step. The first step in bioleaching involves identifying and utilizing specific types of bacteria that have the ability to eat the metal sulfides found within certain ores. Once these bacteria are introduced to the ore, they begin to break down the metal sulfides in the presence of oxygen and water. The bacteria oxidize the sulfides, turning them into soluble metal ions. This results in the production of sulfuric acid and leachate solutions rich in metal ions. The leachate solution contains the metal ions we are interested in. For example, if we're targeting copper extraction, the leachate would contain copper ions dissolved in the solution. The next step involves recovering these metal ions from the leachate. This is usually done by a process called precipitation, where a chemical reaction is used to convert the soluble metal ions into a solid metal form. Electrowinning or smelting might also be used for further processing, depending on the metal involved. To visualize this process, imagine ore as a rocky cake with metal sulfides as the ingredients the bacteria consume. As the bacteria feed on these sulfides, they produce a juice or leachate loaded with metal ions. Finally, through careful processing, we can extract the pure metal from this juice. Comparing bioleaching to traditional mining methods, we can see some distinct advantages. Firstly, bioleaching tends to be more environmentally friendly. Traditional mining often involves extensive digging and the use of toxic chemicals, which can lead to habitat destruction and pollution. The bacteria in bioleaching, on the other hand, can work with minimal environmental disruption. Having said this, bioleaching can release potential toxic substances in the environment, such as sulfuric acid. In terms of cost, bioleaching can be more cost-effective, especially for low-grade ores that aren't economically viable through traditional methods. The bacteria do much of the work, reducing the need for expensive machinery and chemicals. Finally, bioleaching generally requires less energy than traditional methods, as it operates at ambient temperatures and pressures. However, bioleaching also has some disadvantages. Firstly, the process of bioleaching can be slow. Extracting metals via bacterial activity can take months to years, whereas traditional methods are much quicker. Secondly, not all metals can be effectively extracted using bioleaching. Its applicability is generally limited to specific metals like copper, uranium, and gold. In summary, bioleaching is an innovative and exciting alternative to traditional mining that utilizes natural bacterial processes to extract metals in a potentially more sustainable and cost-effective manner. By understanding and applying these principles, we can better address the challenges posed by the depleting resources of high-grade metal ores. In today's lesson, we delved into the limitations of the Earth's metal ore resources and their implications for the mining industry and broader society. We discussed the finite nature of metal ores, the environmental damage caused by traditional mining methods, and the increasing economic costs associated with lower quality ores. To address these challenges, we explored two innovative and more sustainable methods for metal extraction: phytomining and bioleaching. Phytomining uses hyperaccumulating plants to absorb metals from the soil, which are then harvested and processed. Bioleaching employs bacteria to leach metals from ores, resulting in a copper-rich solution. Both methods offer environmentally friendly, sustainable, and cost-effective alternatives to traditional mining practices. This lesson highlights the importance of adopting new technologies to manage our finite resources responsibly and sustainably. Watch the rest of the GCSE chemistry course at Sophos Education.